He is the founder and chairman of Manav Group of Companies and is a patent holder with an experience of 31 years in the field of electrical and electromagnetic safety and reliability. He has also worked with DFCCIS to design an electrically safe and reliable system, which set a world record for transporting 10 million GTKM of freight every day. Today, Sanjeev will talk about enhancement of electrical safety and reliability in smart city. Delegates, so let's welcome Mr. Sanjeev Banerjee.
I would like to look at the entire seminar not in terms of product but in terms of the philosophy of safety and reliability, because this safety and reliability comes when we know the physics behind engineering. It is not about how to do, but it is about why to do. So to find the why, not the how, is very important about the physics of engineering. All these years we are talking about today's smart city, but this smartness is not possible if we do not give significance to the experience garnered by our predecessors, by our teachers. So there is a history of experiences, of the processes and method statements which we have used to solve a particular problem or address it. So all these processes and method statements are inside a library. So these library of incidents, library of root cause analysis, gives us the depth of understanding of not only why it happened, it also shows us how did we solve it. It shows us how can we solve it in future. It also shows us the character of incidents that can happen with the given changing environment using artificial intelligence. So when we extrapolate the incidents and the root cause analysis which we know, and we are able to look at a smaller portion of history, and we are able to extrapolate this to incidents for our future, for our children. Now here comes the IIoT, where we are using them for sensing mechanism, and the artificial intelligence working in tandem with IIoT to take decisions. In this entire network of sensing decision, and there is networking. So our honorable speaker, Mr. Rajiv Kumar, I understand, is a network domain specialist. So this is very key to our science, where Sabita ji mentioned that there is a security in the area. We call it breaching the air gap. So there is security, and cyber security is also very important, where the air gap is breached thermally or electromagnetically or optically, and it can intrude into the network. So we need to have a safe network, and once we have a safe network, we can build a command control and a management of smart safety and reliability. So this is basically the genesis of smart safety and reliability from the point of human development to today. And we are in this process and the world of understanding knowledge, because we understand that information is the lowest pedagogy of knowledge. So, but the information needs to be applied, it needs to be experimented and then researched to reach the higher levels. In Manav, we a company which is trying to understand and unveil what is the buried. And when we are trying to do this, I'm taking few examples because I have just 10 minutes to speak. I will try to restrict my time to 10 minutes. So I've taken two aspects, and something which is inside the ground, something all of us face. 35% of the fault which happens in electrical engineering is due to earthing. And all this, the earthing is there in your house, and it's buried. I'm sure most of you don't even know where is your system. This is the reference system of your house. This is the reference system of a power generating station. This is the reference system of transmission line. Suppose a generator trips due to instrumentation, and one trip, which may take about 7 to 8 hours to pick up a turbine back. The losses are in terms of 3 crores for one trip. Similarly, if a transmission line of 400 kV trips, the losses may be in tune of 13 to 17 crores, 13 to 17 lakhs. So these systems, which are basically very, very key to safety and reliability, what we apply, we apply salt and charcoal, we apply some bentonites, we apply some chemicals, we apply some permanent treatment compounds. But all of this are dead and buried. So how is it possible that we can make these systems talk to us? This is where the action came. We sprung into action, and we were thinking that how do we take these signals from the earth, which entails calcicity, porosity, sodacity, compaction, all these are into picture. And that any signal which is earth, it is earth. The signal is gone. How do we take the signal from this earth and then connect this system to the grid? These were the questions. And then we actually made the sensors. I'm happy and glad that the government of India has given us the patent, where we are able to connect an earthing system in Jammu Kashmir to the earthing system of Kanyakumari, to the earthing system of Jaipur, and to the earthing system of Meghalaya. That means we are able to see the event like a solar flare and its effect in the ground. So once we understand any event which is moving across miles, these sensors are able to look at the earth character and then signal to the grid. And once we have the signal to the grid, then action can be taken. And during this action, there are necessary trips, there are necessary alarms, there are necessary proactive measures. These can be taken in terms of decision making. So these are various sensors, various networking. It is available today. It is available in Wi-Fi, in GSM, in LoRa network. I'm sure I would love to try Mr. Rajiv Kumar's narrowband networking. So yes, these are highly networked systems, and we employed them to areas like on 17th of July. We are launching an app. Now, in this app, if any person builds the house, let him be in Nagaland, he has to just put his GPS. And once he put his GPS, he gets the soil resistivity of that location. And then once he gets a soil resistivity, he just orders it. He knows how he has to make his earthquake. So there is a report which comes to him. So this kind of intelligentsia is now going to be available to the every hectare of Indian land is mapped. This is the dimension of the smartness which we all need to work on. And through these dimensions, we will be able to save the refineries. We will be able to save gas turbines, steam turbines, hydro turbines, transmission, distribution network. It was very interesting to see Mr. Sabyasachi showing that the AT&C losses are between the targeted losses are 15%. But if you are looking at it very carefully, then and break down those losses into components, it is very interesting to see that how much of those losses are due to trips. And those trips can be completely brought down to zero by proactive and preventive measures. So these are one of the systems where we can look at it. The recent past, there has been a lot of news, a lot of discussions on lightning. Now, I designed the tip of the Burj Khalifa, the highest man-made structure on this earth. John Walker was the electromagnetic consultant, but I'm the designer of the tip of Burj. When we look at it from lightning perspective, and so many news comes, I doubt if a man gets killed if he's in his house. But what happens is when the man is outside, there is nothing to alarm him that a lightning is going to fall. But if we have a system which can manage lightning, now this is where we worked out like I just discussed something which is buried under the earth. Now I'm discussing something which is over ground. So we looked at the electrostatic, we looked at the electrogeometric models, and when we looked at it, we could manage lightning. So when we were protecting United Nations data center for the cable which is joining between Africa and India, then we took out that entire data center in a lightning condition, shifted it from the grid power to the UPS power, and in a non-lightning condition, shifted it back from the UPS power to the grid power. Like that, when people died in one of the very important industries in India, they approached us. They said that our people are working in open. Can we have a system that can pre-alarm and my people can run? Can we have a system
where false tripping doesn't happen due to lightning. So during a lightning condition, if I get a vibration, then that vibration alarm which has got triggered due to lightning EMP can be said and can be voted out. So the tripping of a gas turbine may not happen. So this kind of management systems bring into safety and reliability, and it prevents a lot of losses to the nation. So we can not only detect, we can alert, we can protect, we can analyze. And why analyze? Because we can upgrade. So when we are in this dimension of electrostatics, electromagnetics, geothermal areas, we are also into various other areas where we can see the continuous change in electrostatics. So the first question which comes from, I am generally asked, from how far can you see the lightning? Actually, the levels can be adjusted. We can see lightning from even 40 kilometers or even 3 kilometers. But when we look at lightning very carefully, then the 40 kilometers may be a little, it may happen or may not, but 3 kilometers is perfectly timed, but you may not have time to run. So there are various levels of selection of this management system. Appropriately, you will be able to design these systems. I am taking just few examples of smartness of safety and reliability. There are many more smartness possible, smartness of power quality, smartness of electromagnetic management. Suppose there is a panel, as Mr. Ripunjay said, that the beautiful technology ETON has. Suppose there is a spark which has started developing and the entire thing is casted. Can we understand that spark which has started developing? Can we understand that on our screen? Suppose you have a refinery and whose head office is Mumbai, and the refinery is situated all across the globe. So can we understand that there is a spark developing in Russia? So this kind of remote electromagnetic management system, remote power quality management system, and various types of networking, Internet of Things can provide. And today we are in a position to substantially say that these systems are active, these systems are working. It is protecting few of the refineries, it is protecting few of the government establishments, major milestone projects of the world. And that's all I had to say. Thank you very much.